All right, cool. Let's get started. So I'm going to swap over to our document camera so that way we can answer the mahia and make sure we have our... Cool. I like to start on a new page, but it's okay if you guys haven't started on a new page. So first thing we're going to be doing is writing down the date. So what's today? It's the 1st of April. So it is April Fool's Day. Yes.
It's not on.
I can see it's on. So you're not gonna fool me today. I'm mindful because you guys are like a jokey, like tricky trickster class that you're gonna try to pull some pranks on me today. So.
Oh, I already got one line.
All right. The other thing we need to do is write down the fania because we need to know what we are learning today. So we are going to revise what is energy and how it transforms. Alrighty? Are we good so far? All right. So, mahia, today we were thinking about those motions we talked about yesterday and classifying them as balanced or unbalanced. So, I'm going to write down mahia so that way we know what our mahia is, /do now. And I'm just going to create a list so that way it's nice and easy. So, remember, with the mahia, I don't need you to copy down the question. I just need you to write down the answer, but we should write down the answer in a way so that way we know what the question was. So the question was classifying those motions as balanced or unbalanced. So the first one you guys had was stationary. So is stationary balanced or unbalanced? Balanced. All right, the second one we had was acceleration. Is that balanced or unbalanced? Unbalanced. Now we have thrust force and we have friction and drag. Which one will be greater in acceleration's case? The thrust or the friction? The thrust. So I'm going to write that down so we remember that. Thrust is greater than friction. All right, the next one we had was constant speed. Is that balanced or unbalanced? Balanced. And then the last one was deceleration. Is that balanced or unbalanced? Unbalanced. Now with deceleration, what force will be greater? Friction and drag. I'm just going to write friction because I don't have enough space. So friction is greater than the thrust. Cool. I'll leave that up for a moment to make sure you guys have that written down. And then we will talk about today's lesson. Cool. And let me unfreeze that screen. There we go. All right. So for today's lesson, I'll wait till you guys are done chit-chatting. I'm being very nice right now and not putting in a seating plan, but your behavior will decide whether or not I make a new seating plan, which reminds me, I should get the behavior beans out. You guys have actually done quite well. You have gotten enough so that way everyone gets a lolly. Yay! But that means you have to start over. So should we keep saving it so you guys can earn one of the bigger prizes?
No! Yes! No! No!
Yeah. No! Because you guys, I think, we have a Kahoot. We have a Kahoot today. We also have a lolly-based activity, so there will be opportunities to have something nice and sweet, okay? So let's keep collecting our beans.
No!
Kararuki, come on. That's not how we behave here at Edgewater. Huh? You said lolly. All right. Cool. So for today's lesson, we're going to be revising what is energy and also how it transforms. So this is stuff that you guys did during the remote learning, and I just want to revise it to make sure that you guys have it in your brain. So, lesson plan for today, what we're going to do is first off give some notes on what is energy. Then we will have our Kahoot. Then we have a little lolly mass break. Then we'll do energy transformations, and that's some more notes. We'll see a cool video on how people have used gravity to create light. And then we will wrap up with some science world work. Cool? All right, moving on? Okay. So, on our checklist today, we are looking at number 10 and number 11. So, let's go to our checklist page. 10, I can explain the conservation of energy. And number 11, I can state how energy is transformed from different types. So we can tick off number 10 and 11 today. I should actually probably do different colors when we tick them off so that way you guys can see the new ones. I'll do that next time. All right, are we good? 10 and 11. It's also on the sideboard if you guys ever miss it. Cool. Let us talk about what is energy. So again, we're going back to the document camera, and I'm going to start writing notes for you guys, and we'll have the notes all together. So I just have to pull it up so that way I can see it. All right. I might actually use a little bit more color in my notes just to help kind of distinguish it because it's all very bland. But you guys don't need to use color. If you guys want to just use normal color pens, just go for it, okay? Now, I see a device out, and that device needs to be closed. I have not given you guys instruction to use those. I want the screen shut. If you want, you can just hold on to it. Yeah. All right, so the first thing I want us to talk about is the word energy. So with that energy, we're going to put it in the center of our ideas. Now I'm going to start using some more colors. I think colors are fun. All right. So we have this whole page here, and we want to use, again, another mind map, because mind maps are great ways to see how things interrelate. It also means we have to do a little less writing with a mind map, because then I'm not writing definitions. All right. So the first thing in the middle I want us to write down is energy, because that's our big idea. Now I'm using a pink marker, but don't feel like you need to use a pink marker as well. You can just use black. I'm just trying to do different colors to make the notes more interesting. All right, so what is energy? Well, energy is the ability to do work. Now that is going to be my key idea, so I'm going to make that a nice bubble. I like to do the bubbles, not the bubbles, I should say the clouds, whenever I have my key ideas, so that way I can kind of distinguish it. Are we good so far? All right, I'm going to move this up a little bit because we're going to start adding some more ideas to it. So I should see a cloud and some space, so that way we're ready to add some ideas off of that cloud. Cool. All right, so there are two different categories of energy. The first category is our active energy. So I'm going to bubble that off, and we're going to write active. Now we need to explain what active energy is. So active energy is energy that I can detect. The other thing about active energy is that I detect it based off of movement. So I see that as movement of waves or movement of particles. Now, that's one of my bigger ideas, So I'm gonna bubble that one. Are we good with that? All right, so let's think about some different types of active energy. The first one, actually, let me ask you guys, what do you think are some active forms of energy? Alpha. Nuclear is, correct, that is a type of energy, but it's not active, it's actually potential. Yeah, Kararuki. Huh? Solar, yeah, let's write that one down. So, for example, solar would be an example of light energy. The other one that could be solar is known as electromagnetic. That's a really big word to say everything. Yeah, wind is a type of power. What is the wind doing with the windmills? It blows it, but what's more specific? It makes it move. So there's a fancy word for move energy, and that is kinetic. So there's lots of energy in movement, right? Do you think if I move faster, I have more kinetic energy? Yes. So if you're hit by a car that's going 20 kilometers per hour versus being hit by a car that's going 50 kilometers per hour, which one's going to hurt more? 50. The 50. So something to keep in mind. If we move faster, there's more energy. What about if I am heavier, if I'm more massive? So if I'm hit by a truck versus hit by a car, which one do you think is going to do more damage? The truck. So do I think more massive, more energy? Yeah. So more mass, more energy. All right, there's a couple of other ones that we can think of as well. Now, right now, it is really, really hot. But in the winter, what do? We freeze to death, but in order to not freeze to death, what do we turn on?
Fire.
Heaters, fire. And what the next type of heat then, the next type of energy then is heat.
Thermal.
Yeah, thermal is another way to describe it, if you want to be fancy. Right, there's two more for the active energy. Now, right now, I am talking to you. What is that?
Coal.
Coal. You're listing good examples of energy. What? Servile energy? Sonar. Sonar is a good word. Sonar is more specific. I want more general. So sonar is representing sounds, right? So sound is another form of energy that we could have. So sound is a form of energy. Whenever you guys have a big speaker and it has a good bass, do you notice the vibrations? You can feel it? Thump, thump, thump. Yeah. All right. Last one we can see right now. I see it with my laptop. What is making my laptop work? Alpha. I have it plugged in. What does this plug provide? Electricity. Sarah? Yeah? Exactly. So that power, that is an example of an active form of energy, electrical. But with that electrical, there's two types. So I'm going to write down that this one's talking about current. All right. So those are my active forms of energy. I'll leave that up for a moment so you guys can make sure you have that copied down, and then I will start on the inactive. All right. Let's talk about the inactive energy. So it's the opposite of active. Actually, we should say a better word for inactive is potential. I know. I try to make it less notey because that way we're just doing mind maps, so it's less. All right, so I'm starting to do some more writing, so you guys should be doing some writing as well. We are talking about potential energy, also known as stored energy. That is one that we cannot detect
Coal.
until it becomes active. Mm-hmm.
Does fire count?
So fire is a form of energy, and we can talk about what type of energy that is in the second half of the lesson.
Does coal count?
Yeah. Yes, it does. All right, so I'm going to again do a bubble around there. So with that, you guys talked about coal. Do you know what type of energy coal would be classified under?
Fire.
Not, well, it burns to make into a fire. Ella? Is that a hand up? Coal. What type of energy do you think it is? Coal, like the black things that you use in barbecues.
Internal.
Internal? That's a good word to say. Internal, like
Yeah.
energy. The word I'm looking for is chemical.
Chemical. Oh.
So chemical energy is what we refer to that. So some examples would be coal.
Fire.
You guys mentioned that one. We'll talk about fire later.
Battery.
Battery is another type of energy. You are right, and that's my electrical again. But you can also call it a chemical. What other chemicals do you think we get energy from? What do we? Alpha.
We also have nuclear energy.
Yeah, nuclear is another list. I'll put that on here.
We get that from powder. What kind of powder?
Now, with chemical energy, where do we get our chemical energy from, do you think? Someone new? Anybody want to take a stab? Where do we get our energy from?
Yes.
No one wants to talk. Alpha, where do we get our energy from?
What's it called?
You just had it.
Yeah, I forgot it.
Daniel.
Space.
Daniel should have the device closed. Closed. I want the screen closed. No, that's still 45. There we go. What'd you guys just have? Lunch. Lunch is food.
Good boy, Master.
All right, what do we put into cars? Gas. That's another chemical energy. All right. Can't see it. Oh, you guys should have told me that. Let me fix that. Oh, it's frozen. Let me restart.
Sorry.
No, I'm glad you told me. I'm putting it back up. There. Okay? All right. Alpha. Does so fire, that wood burning, the wood itself, huh? Fire alarm. Guns? Yeah.
Do they use chemical energy?
That's a good question. I'm not really sure. I would say it's probably mechanical. So mechanical's another one. So with mechanical, we can write gun, if you guys want, as your example. All right, there's one more that we haven't talked about, but we talked about a lot when we're doing forces in motion. So, what happens with this glue stick if I let it go? Falls to the ground. So what's one last energy? Gravitational. So with gravitational, do you think the higher it is, it's going to have more energy, or the lower it is? Higher. So we'll add that. Higher, more energy. All right, cool. That's all for that section of notes. I'll pause it on the board so you guys can have a few more minutes to write that down. And then we have our Kahoot. Oh, sure. All right. What type of energy is the result of vibrating objects? Think about how I said that's feeling the vibrations. All right. What is the main type of energy in the surfer? Yeah, kinetic, that movement. Oh, sorry, I should let you guys see it was. All right, which of the following is active energy? Oh, ooh, you guys made a little mistake. Oh, sorry. Heat energy. Remember, all those other ones are potential. Ooh, that hurt people. All right, what type of energy is stored in the cereal? What type of energy would the cereal have? It is chemical. Ooh, that really affected it. All right, X-rays are which type of energy? It has to do with the electromagnetic spectrum. So which one is the electromagnetic spectrum? Ooh, light.
If you know it doesn't.
Ooh, Sarah, that hurts ya. All right, objects that are high up. What type of energy does it have? Gravitational. All right, which of the following is potential energy? Oh, we didn't actually talk about this one. So you have to figure it out from cross elimination. Hopefully it's obvious though. Yeah.
We were totally guessing.
So I totally forgot to give you guys elastic is one of those potential energies. Elastic is like when you have the rubber bands and then you flick them. That is elastic energy. Ooh, that hurt. You're out of 10. I need you to come down to maybe about a 7.
No, we're to a 9.
All right. What type of energy is due to the movement of atoms? Oh, that hurt a lot of you guys. Heat energy, because heat is the vibration of those atoms. Oh, didn't change anybody. All right. The movement of electrically charged particles. Which type of energy? It is electrical. Oh, that changed it. All right, last one. What type of energy is an ultrasound? Don't let the word ultrasound trick you. Actually, it's not even on there. Ultrasound is actually a light energy. All right, so the top three come on up and grab themselves a prize. So, come on to and Ashland, Hannah, and Aya. There's one prize and there's one thing. supposed to eat in a science room.
No!
Yeah. So, you guys didn't win. So it might kind of be nice, because it's also a Friday, if we had a little lolly break / fast break. Obviously we're not allowed to take our mask off inside, and we shouldn't be eating in a science room. So what we'll do is we'll go outside, and we will have a little lolly break out there. All right. So what I need you guys to do, time out, is in a moment we are going to go outside. We are going to go down the ramp. We're going to turn right to the field, and I want you guys to stand in a single file line. All right, cool. Alrighty, cool. Let's do the second half of the notes. So I know, I'm sorry, but I gotta make sure you guys remember things, and one of the ways I can make sure you remember things is if you write it down. All right, cool. So, I'll wait till you guys are done with the noise and ready to listen up. So, devices should now be closed because we don't need them. We should be back to our notebook for science. All right? Cool. So, the reason why we did that lolly break was because I was trying to introduce the next section for energy, which is about transformations. So, you guys started by eating that lolly. Now, what type of energy was that lolly?
Chemical reaction.
Chemical energy, and that was one of our potential energies. And then what did I make you guys do? Run, because I'm a very terrible person. What type of energy is running? Kinetic energy, because it's the movement. So you see how you took that energy that was chemical, and now we transformed it into something that's active. So, because that's my life, we'll try again. We'll end that task. We will open it up. Reboot. There we go. All right. So remember how I said potential energy, we can't detect it until it becomes active. The way it becomes active is by transformation. Now I'm going to kind of squeeze transformation in there. All right, transform. Now we can transform them in both directions. So between the active energy bubble and the potential energy bubble, I want you guys to draw a double-sided arrow and write the word transform. Because that's what we were doing. We were transforming that energy. I should also have you guys write down, because that was I forgot to do that, is elastic. Forgot to give you guys elastic in that list. So we transform it. All right, can I move it?
Yeah.
Yeah. So, can I move it? So, what we need to think about then as some of our vocabulary is the word transformation. Sorry, not transformation. Conservation of energy is what I want us to think about. It is quite laggy, isn't it?
Yeah, I think it's the internet.
All right, conservation of energy. Have you guys ever heard of the word conservation?
Uh-huh.
What have you heard it in the context of? Like conserving stuff, conserving resources, conserving your money.
Yeah.
What else have you maybe heard the word conserving for? What about like outside with the trees and the plants and stuff?
Like
And
Conserving nature.
Conserving nature, conserving the environment. So the word conserve is to make sure we don't like waste it, right? So conservation of energy, that law is very similar. It's about saying how energy cannot be created or destroyed. It can only be transferred. Sorry, transformed, I should say. So, let's think of some examples. So you guys were thinking about that fire, right? So if I was thinking about a fire, and we have our wood, and then that wood's burning. So, what's the energy starting as, if we're thinking about the wood?
Money.
What type of energy would wood be? Do you know? Out of our list?
Is it chemical?
It's a chemical. So as fire burning, we would have chemical energy. And what would it become?
It will become dangerous and it could burn your life.
What do I feel when I sit next to the fire?
Heat.
Heat, warmth. So heat is the energy that it changes it into. What else about the fire? Why do I light it at night sometimes?
So if you can see through the dark.
I can see. So light and heat.
But there's an easier way. If you're in the forest,
Yeah.
put the torch down when it's lit, and then you can see.
Yeah, torches would be easier.
Dang it! So you
All right, I have a few more examples to make sure you guys understand this transformation. I'm just trying to find my notes for you. There they are. All right. What about a person riding a bike?
Isn't that?
That's kinetic.
Hey, don't
That's kinetic.
say it. Don't you dare say it. Kinetic energy.
So a person riding a bike. So we know that they have kinetic energy that they are moving, but where do they get that energy from?
Their legs.
Their legs, but where do those leg muscles get the energy to be able to pump and move?
The brain.
What do we need to do every day? Chemical, eating.
Drink, sleep, eat.
So chemical to kinetic. So we have a little person on a bike. I'm sorry, I'm not a very good artist. Here's a little person riding a bike. What other things do you think they're using that chemical energy for? Are we warm?
No, actually.
We're warm-blooded, so we're also using that energy to make heat. What else are we doing? I'm making some noise right now, so what energy am I converting my chemical into?
Sound.
Sound. Somebody's riding the bike who's probably making some sounds too.
What about thinking, miss?
Thinking, yeah. I wonder what thinking would be classified as.
Your brain uses electrolytes.
All right. What about thinking back to camping? If I have a torch, we're now going to see a multi-step. So right now we have 1 going to 2 and a list. If I have a torch and there's a battery inside it, what's the energy starting as? Before it's electrical. What's it before electrical? What's the battery?
It's made of metal.
It's made of metal. It has chemicals. So you see how we have a potential energy going into electrical, and then what's the final output energy that I see?
Light.
Light.
Wait, mechanical as well, right?
Huh?
Torches.
No, I wouldn't say that a torch would be mechanical because there's no like wind up. So like I would think about like a wind up toy as mechanical. Yeah. All right, and then one more example. What about a car racing at night?
There's of course the sound.
No, there's a police chasing them.
Yeah, well then they're gonna stop. So the petrol is what? If I have a car that's
Chemical.
Gasoline. It's gasoline.
Gasoline, which would be a chemical.
Yeah, stuff with the gas.
So what is that chemical energy getting converted into?
Songs.
Songs, but before it becomes sound in our radio, what does it need to be as an intermediate?
It needs to be
What do we have as the intermediate up here?
the engine.
Electrical. So do you see what I'm saying?
Stop.
Chemical to electrical to the radio, which is our sound.
What if we use the manual on this?
If you're using the manual, so if we're doing a manual car and we have a transmission, we have that chemical energy, we have a small burn and combustion, and then what's going to happen to the car?
So it's burn up and die.
It's starting to move, isn't it? So move is what? Kinetic? Yeah. What else do we use the electronics in the car for? If I'm driving at night, what do I need to have? Light. So sound and light is what that energy is being changed to. So the reason why I give you guys that example as well is because I want to show you guys different conversions. So in this case, we have very simple conversions, just going from one step to another, and maybe a few multiple types. Also be mindful that it can be transformed multiple times or in different ways as well. So we can divide up how that energy gets transformed. But the important thing is that we are not making new energy, we are not destroying the energy, we are just changing what it is. Are we okay so far? Yes? All right, what time does this period end? We end at 1:10. How much time do I have left?
We got 1 hour left.
Cool, we got about just over 20 minutes. All right,
Oh.
can I move it?
What?
Are you guys ready for me to move it?
No.
Yes? Let me just do a walk around check. Make sure everyone has it written down.
Wait, man, so I got to the top.
Oh, conservation? Oh, you get it written down?
No.
You gotta get it written down.
Is this still
Right, well, the password.
Yo, I'll steal her too.
Anybody else?
The next one, you guys your hand.
Let me write this down I'm gonna change the screen. Is that okay?
That's your book.
Yeah, that's my book. That was what I was writing on.
Oh.
I'm giving it to you guys so you can finish your notes. All right. Yeah, but you have to come to the loan shark. And when you guys are listening to music, you are listening off your device, not off the phone. All right. Oh, get your headphone. Yeah, those white ones. And so what? Take that.
I have two pins. I can use my own. Yeah.
You've already given me something, so you go ahead and take headphones. Daniel, take that so you remember.
Yeah.
If you're finding that work too difficult, let me know. I do have an alternate activity you can do. So you find those questions too hard, I do have an alternate. Ooh, someone did not return that very well, did they?
Awesome.
No, I'm saying the headphones.
I still need that.
That's usually your lesson. Right, you guys all enough for that?
Hey, miss. Somebody's probably gonna get one. What are you doing? It's kind of fruity. Oh, someone drew on my book. I thought it's someone actually. Harry. 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 Someone's being It's for poor guys.
People listening to music, that's why. People listening to music.
You want the other question, or you want to try to do those questions about? Yeah, you can send the other one. Yeah. Yeah, that one is that's why it's easier worksheet. You want to try those questions? You want to try this one? Alright, go for it. You want to try this next one? I don't think it's so long. There's a lot of knowledge. Alright, Sarah, what about you? You want to do this? See what you do here? Yeah, it's a long track. Okay, yeah.
Why is it that people always love to single stuff?
People just aren't careful with things that they've given you.
Yeah. No, this. Thank you. Why not?
You want something a little easier, you have me do those questions. Is it okay? You want the easier? Because I'm sure you want the easier. You want to do this as Alright, make sure you're getting the work done. So I want you to answer question 1, and then question number 4, 5, and then 12. No, you gotta use the device. No, you gotta use the device.
Wait, this. Do we need this?
There's now question 1 here. 4, 5, and 12. There's only 4 questions. I don't have all those questions. But
music, or would rather get this done?
Oh, I just forgot to stop the recording. All right. Cool. All right, team. The bell's gonna go in a few minutes, so I just want to recap today's lesson and also do the cleanup routine stuff. So today we were revising what is energy and how it transforms. You can go ahead and tick off the I'm ready for number 10 and 11. But I think for most of you guys, you probably, oh, it's still frozen. We probably maybe need some more practice on 11 because we didn't finish the science world work. So I think probably 10 could be ticked off, but maybe 11 needs a little bit more time. So with the cleanup for today, if you want to leave your science notebook with me, that's fine. Drop it in this box over here. I need you guys to return the science world books as well. We need to spray down the tables. You guys are my last class of the day, so you need to put up the chairs. We need to spray and wipe the tables before the chairs. And the last thing is that you guys can close my windows. You're allowed to jump up on the bench to close the windows. I know they're quite high up. All right, so go ahead and pack up. Really great work today. You guys get your coffee beans.
Let's see where the flies.
Huh? Oh, the blinds you just leave. Just the windows. Oh, with those blinds, open the blinds so you can reach the windows.
Last one,